Alright, let's try to set up this problem. It says an employer group requires 5 people be chosen for a committee from a group of 12. Now the employee group has 7 women and 5 men. What is the probability that 3 of the people chosen for this committee are women and 2 people chosen for the committee are men? So our probability of the event here is going to be the number of possibilities over the sample space. So let's get the number of possibilities. So let's get what we want. And what we want here is a group of women and a group of men. If we zoom in on women here, we see that we have a total of 7 and we want to choose 3 to be part of this committee. So the way in which we can choose a woman is by calculating this combination 7 choose 3. And now let's do the same for men. Let's zoom in on men here. Here we have 5 men, and out of the 5 men, we want 2 of them to be part of the committee. So the way in which we can choose a man is going to be determined by this combination 5 choose 2. And this is going to be the number of possibilities. That is going to be the numerator in our ratio that's going to help us calculate the probability. Now that we have the number of possibilities, we want to emphasize we want to figure out what the sample space is going to be. And remember that the sample space is the total possible outcome. So here we want to get the total, and the total I believe was 12. Here we have a group of 12 people. So out of a group of 12 people, we're going to choose 5 people to be on a committee. We want 5 people to be chosen for a committee from a group of 12. So we get 12 choose 5 as the sample space. And you can notice right here that these 3 plus these 2 give us the 5 here. So let's calculate the probability by first writing our probabilistic statement. So here we have the probability of selecting 3 women and 2 men is equal to 7 choose 3 times 5 choose 2 all over 12 choose 5. So let's go ahead and calculate each one of these combinations. Let's begin with 7 choose 3. So we have 7 choose 3, and that's going to equal 7 factorial all over 3 factorial. 7 minus 3 is 4 factorial. Let's expand 7 all the way to 4 factorial. That's going to cancel out the 4 factorial from the denominator and the numerator. So now we have 7 times 6 times 5, which gives us a total of 210 over 3 times 2 times 1. So we get 210 all over 6, and then that's going to give us 35. Now let's calculate 5 choose 2. So here we get 5 factorial all over 2 factorial. 5 minus 2 is 3 factorial. So let's expand 5 down to 3 factorial. So you get 2 factorial times 3 factorial. Let's cancel out the 3 factorials. We get 5 times 4, which is 20. 2 factorial is 2 times 1. But 2 times 1 is just 2. So 20 over 2 is 10. So on the numerator, we have 35 times 10, because 35 is the same thing as 7 choose 3 and 5 choose 2 is the same thing as 10. All we gotta do now is calculate the denominator here. So let's go ahead and calculate 12 choose 5. So 12 choose 5 is going to equal 12 factorial all over 5 factorial. 12 minus 5 is 7 factorial. Let's expand 12 factorial down until we get to 7 factorial. So 9 times 8 times 7 factorial. The 7 factorials will cancel out. So let's calculate the numerator here. I'm going to get a total of 95,040 for the numerator. The denominator, 5 factorial, is the same thing as 5 times 4 times 3 times 2 times 1. So we get 95040 all over 5 times 4 times 3 times 2 times 1. That's equal to 120. And then once we divide this out, we get a total of 792. So 12 choose 5 is the same thing as 792. So let's go ahead and substitute that in. So we get a 792 right here. So let's calculate this ratio. 35 times 10, that's 350 over 792. And let's see what the approximation gives us. And I'm getting an approximation of 44.2%. Cool. Okay, 44.2%. So let's try out one more example. Let's try out this one, example 5. It reads, there are 12 marbles, 4 are green, 8 are yellow. You randomly select 6 marbles. What is the probability of getting 2 green and 4 yellow? And we want to get the number of possibilities and divide it by the sample space. So let's begin with getting the number of possibilities, and that's basically what we want. So what we want is we want green and yellow. So let's begin with green. So we want 2 green, and there's a total of 4 of them, 4 green marbles. So the way in which we can get a green is by calculating 4 choose 2. And now let's look at yellow. We want 4 yellow marbles, and we have 8 total. So out of the 8, we want to choose 4 of them. So that's what we want. Now let's focus on the sample space. So for my sample space, I want all possible outcomes. So here they're telling me that there's a total of 12 marbles. So out of the 12, I'm going to select 6. So 12 choose 6 is going to be my sample space. And again, here you can see that the 2 plus the 4 make up that 6 marbles that you're selecting. So now let's set up our probabilistic statement, and let's go about by calculating that next. So check this out. So the probability of getting 2 green and 4 yellow marbles is going to be equal to 4 choose 2 multiplied by 8 choose 4. We're going to divide that by 12 choose 6. So let's begin by calculating 4 choose 2. So 4 choose 2 is the same thing as 4 factorial over 2 factorial. 4 minus 2 is 2 factorial. So here we expand 4 factorial down to 2 factorial. And one of the 2 factorials in the denominator is going to cancel out with one of the numerators. Well, with the 2 factorial on the numerator. So now we have 4 times 3, which is 12. And 2 factorial is 2 times 1. So we get 12 over 2, which is 6. And we can substitute this 6 or replace it for the 4 choose 2 here. So let's begin. So we have a 6 times, and now let's calculate 8 choose 4. So 8 choose 4 is the same thing as 8 factorial over 4 factorial, and then 8 minus 4 is 4 factorial. So let's expand 8 down to 4 factorial. And now the 4 factorial on the numerator is going to cancel out with one of the 4 factorials in the denominator. And we get 8 times 7 times 6 times 5. We get 1,680 for the numerator. 4 factorial is 4 times 3 times 2 times 1. So we get 1680 all over 24. And then 1680 divided by 24 gives us a total of 70. And now we can replace 8 choose 4 by 70. So here we have 6 times 70. All we have to do now is calculate the sample space, which is 12 choose 6. So let's go ahead and calculate that. So 12 choose 6 is the same thing as 12 factorial over 6 factorial. 12 minus 6 is 6 factorial. So we expand 12 down to 6 factorial. And the 6 factorial in the numerator is going to cancel out with one of the 6 factorials in the denominator. So let's calculate the numerator here. And I'm getting 665,280. We're going to divide that by 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. So we get, and then 6 times 4 times 4 times 3 times 2 times 1 is 720. So 665,280 divided by 720 is 924. So that is the sample space. Let's go ahead and replace our sample space with 924. In here, we can do this now. So 6 times 7 is 42, so we get 420. 6 times 70, and then we have 924 on the denominator. So let's get the approximation, and I get about 45.5%. And that's it. All right, so then I'll see you next in the next unit.